Hey kids, Mr. Murray here, Mr. Murray's Mathland. Today we are talking about factoring by the grouping method. And grouping is the method typically you'll want to use when you have four or more terms. Four or more terms. And we still know that the first kind we should always look for is a greatest common factor. That is our most classic kind of factoring. It's the first kind we learned, and so you still want to look for that first. Okay, so before we actually get to a grouping problem, these two examples really lead into it, and these two have to do with greatest common factor, and that's all grouping really is. You'll find it's just a more complicated version of greatest common factor. So if you can understand these first two, it'll go a long way towards getting the grouping problems in a minute. So number one, when someone says to factor this, I'm looking for, is there a greatest common factor? Is there something I can take out? And I notice each term has an a. So I can definitely take that a out, and then we make a set of parentheses, and there's going to be two terms on the inside. What's going to be left when I factor out a? 6x. And don't forget, what's really in front of that a is a minus 1. So I'll have a times 6x minus 1. And as always, you could check by distributing. That's how you can check any factoring, right? You're just kind of undoing multiplication. You distribute, you'll get back what you started, so you know you're good. Okay, easy enough, right? If we've gotten this far, greatest common factor should be pretty okay. That's a pretty easy example of it. But look at how similar number 2 is, even though it might look confusing. It's really just the same problem, only instead of a, it's 6x times x plus 5, and instead of minus a, it's again minus x plus 5. So I'm going to treat this the same way, that just like I did the a, that's a common factor that I can take out. Each of these terms has x plus 5, so I'm going to take out that x plus 5, and then I'm going to immediately make a set of parentheses, just like I did in the first problem. And then when I take x plus 5 away from each of these, what am I left with? There's a 6x, and what is really in front of here? Minus 1. And there we go. Same idea. Again, only instead of taking out a, I took out that whole quantity, x plus 5, which might look a little more confusing, but it's the exact same idea. And some people, when they do these problems with the common quantities of x plus 5, for example, some people like to put it second, kind of put it to the back and say, hey, it leads off with the 6x and minus 1, so I'd like to put 6x minus 1 as my first quantity. Doesn't really matter, of course, when you're talking about multiplying two things. The order does not matter. So either of these are good if you happen to see a multiple choice or something where they're switched around. Both good. Okay, so we're about to do a grouping problem, the first real grouping problem, and it puts these two ideas together here. If you can get to this, that's the goal here. You're going to see in a minute. If you can get a common quantity there, I just factor it out, just like I did here, even a simpler version, right? Okay, so take a look at number 3. We have 15xy minus 10x minus 3y plus 2. First, I would look, is there a greatest common factor I can take out of all 4 terms? I still want to look for that. No, there is not. So this is where we think about using grouping when there's 4 terms. And here's what grouping is. Since there's not a greatest common factor I can take out of all 4, I'm going to think of maybe this as being 2 smaller groups, 15xy minus 10x and negative 3y plus 2. Now out of that first group, what can I factor out? If I just focus on the first 2 terms, I can take out 5x, right, out of 15xy and minus 10x. I can take a 5 and an x out. So when I take 5x out, make a set of parentheses, right? 5x times what gives you 15xy? 3y. 5x times what gives you negative 10x? Minus 2. Okay, so this is only part of the problem. I'm certainly not done, but that first group is done. And now when you look at the second group, negative 3y plus 2, there's not really anything you can factor out other than 1 or negative 1. And we don't typically think of doing that except here in this problem as part of this larger problem. And one thing I'm going to give you a hint about is that if you have a minus leading off the second group, typically you're going to want to factor out a negative. And in this case, the only thing I can take out is negative 1. But I'm going to do that. So when I take out negative 1, negative 1 times 3y would give you that negative 3y. And negative 1 times what would give you positive 2? Minus 2. Right? Careful, when you factor negative 1 out of this whole group here, it changes the sign of that second term also. Right? If you distribute, you'll get negative 3y plus 2. And this is what you want, because look at, we're not done. This is not considered factored, as is when you have a minus in the middle here. But you've just made it look like the second problem there, where there's a common quantity. This common quantity is 3y minus 2. So if you can get to this point, you're one step away from being done, because now I can factor out that common quantity. They each have 3y minus 2. I'm going to take it out, and then I make a second set of parentheses, and what goes in there? 5x minus 1. And there we go. Done. That's factored when you have 3y minus 2 times 5x minus 1. See, no plus or minus in between the groups. Factored is things being multiplied, a series of products. So that's that. Or again, you could write it as 5x minus 1. Some people like to put the 5x minus 1 part first and the common factor second. Doesn't matter to me either way. Okay, so just one more example of this, and that should give you all you need. It's just a matter of practice after that on your own. But number 4 here, is there a greatest common factor I can take out of all 4 terms? No, there's nothing that goes into all 4 of those. So I try grouping. I try thinking of the first 2 terms as a group of their own and the second 2 terms as a group of their own. What can you factor out of that first group? I can take out 4x squared out of 12 and 20 and x cubed and x squared, right? So take out 4x squared, make a set of parentheses. What goes inside? 4 times 3 will give you 12, and x squared times x gives you x to the third. 4 times what gives you negative 20? Negative 5, and that will not have any x's because we took both of them out. Okay, that one's done. Now let's take a look at the second group. And it starts off with a positive, so usually that means you're going to factor out a positive. What can I take out of positive 21 and negative 35? I can take out a 7. That is the greatest common factor. So when I take out a positive 7, make a new group. 7 times what gives you 21? 3, and x for that 21x. 7 times what gives you negative 35? Negative 5. And again, here's what you're hoping happens when you do grouping. You should end up with the same quantity here and there. If you don't have that, either you made a mistake or the whole thing doesn't factor. But at this stage, things should be factoring, so look for that same group. If you don't have it, maybe you messed up a sign or didn't take out a greatest common factor. And if you get to this point, you're one step away from being done, because what can I do? Take out that common quantity of 3x minus 5, make a new set of parentheses. What goes in the second group after you take 3x minus 5 away from each? 4x squared plus 7, right? It's just distributing kind of this whole group to 4x squared, and this whole group to positive 7, if you like to think about it that way. And there you go. And again, you could check your whole answer to any of these by just multiplying it out. So in the case of something like this, that would mean foiling, right? Do your first, your outer, your inner, your last, and you should see you end up with the original problem. Okay, so there you go. There are 2 grouping examples and hopefully a little intro into why grouping works. If you have any follow-up questions, feel free to ask.